A significant development in computer science is quantum computing. Amazing to consider that it all began with an observation of the peculiar characteristics of light. Richard Feynman was one of many innovators in quantum computing who demonstrated the viability of these systems and predicted their role in the future of computing. Quantum computers have been around much longer than you might imagine. In 1997, the first quantum computation was performed using NMR on molecules of chloroform. These days, we try to label everything with the quantum phrase. Even so, there are still a select few uses for the seemingly unlimited array of quantum technologies that are truly astounding. Watch till the end to discover the most interesting and fascinating facts about quantum computers. 10. Improving cancer treatment. One of the biggest causes of death worldwide is cancer. In fact, 1.7 million people died from respiratory malignancies alone in 2016, according to a recent World Health Organization survey. However, the chances of recovery through treatment are significantly higher if cancer is discovered at an early stage. There are numerous approaches of treating cancer. One is surgical removal, and the other is radiation. In radiotherapy, beam optimization is crucial since it's vital to make sure that the radiation affects healthy cells and tissues close to the tumor site as little as possible. There have been numerous traditional computer-based optimization techniques for radiation in the past. Researchers at the Roswell Park Cancer Institute developed a new method in 2015 that accelerates radiotherapy optimization 3 to 4 times faster than a conventional computer by using quantum annealing computers, such as those made by D-Wave. 9. Better traffic flow. Many of us have experienced leaving for work early in the morning only to find a traffic gridlock waiting for us. The scary realization that you'll be late for work follows. By tracking traffic and offering users alternate routes, Google has been attempting to solve this issue. Volkswagen is pushing it further with their studies, though, in an experiment conducted in 2017, Volkswagen sought to address the issue of traffic by enhancing the flow of traffic rather than by monitoring it. They employed quantum annealing computers and the quadratic unconstrained binary optimization method to determine the best path for a certain set of cars and potential routes. They have so far tried this with 10,000 taxis in Beijing to demonstrate how their approach can optimize traffic flow much more quickly than a traditional computer. Volkswagen employed a D-Wave quantum annealing computer to process the data, which has led many people to doubt their assertions. Numerous scientists contend that the quantum annealers D-Wave produces do not provide the considerable speedup that Volkswagen claims. 8. Better mobile data coverage. Everybody has experienced a situation where the cell data reception is so poor that it would be preferable to utilize the sluggish Wi-Fi hotspot at the nearby coffee shop. Well, it appears that Booz Allen Hamilton may have, of course with the aid of quantum computers, discovered the answer to the terrible network coverage problem. They claim that it is challenging to determine the best satellite coverage in a 2017 paper. This is due to the fact that there are numerous alignment combinations that could exist, and it is very challenging to examine all of these combinations with traditional computers. The answer: they contend that the ideal satellite coverage position can be determined with the aid of D-Wave's quantum annealing computers and the previously mentioned QUBO approach. While the satellites might not be able to cover every area with poor coverage, the chances of finding a location with better reception are greatly improved. 7. Simulate molecules. Because it enables us to comprehend the structure of molecules and how they interact with one another, molecular simulation has become a vital area of study in biology and chemistry, but it also aids in our search for novel compounds. Although older computers may be able to model these molecular dynamics today, the complexity of the molecules in a simulation is constrained. This barrier can be effectively broken by quantum computers. They have only so far been applied to the simulation of tiny molecules, such as beryllium hydride. Although it might not seem like much, the fact that a 7-qubit processor was used to simulate it suggests that, if we had access to more qubits, we might be able to run highly complicated molecular simulations. This is due to the fact that as the quantity of qubits increases, so does the processing capacity of quantum computers. Researchers have also used other technology, such as quantum annealing processors from D-Wave, to develop simulation techniques that may be equally as effective as existing ones, if not quicker. 6. Break currently used cryptosystems other than RSA. Some of us may be aware of the concern over the potential vulnerability of cryptosystems like RSA or DSA to quantum computing. Since certain cryptosystems produce keys based on prime factors using prime numbers, this appears to be the case for some of them. Quantum computers can determine the prime elements necessary to construct the key significantly more quickly by employing a technique known as Shor's algorithm. algorithm. What about the other cryptosystems, though, that do not use prime numbers as a means of generating keys? Another approach, known as Grover's algorithm, may be used to brute force a key more quickly than a traditional computer. This is faster than a conventional computer, although not by as much as Shor's algorithm would. This implies that in order to even try to crack these cryptosystems, we would require quantum computers that are much faster than the ones we now have. Even yet, there are some cryptosystems that are invulnerable to attack by quantum computers. These encryption techniques fall under the heading of post-quantum cryptography, RSA, which is frequently used in digital signatures, would appear to be outmoded overall. Nevertheless, if you are enjoying the video so far, do well to smash the subscribe button, like and leave a comment on your thoughts about quantum computers and their uses. 5. More human-like AI. The study of artificial intelligence is currently quite popular. Using machine learning and neural networks, scientists have been attempting to make AI more human-like. When quantum computers are added to the mix, the already terrible situation is elevated to a whole new level. Matrix algebra is used to compute the processing done by neural networks, which operate on datasets that are based on matrices. However, the essential structure of quantum computing makes it so that matrices are frequently utilized to specify and pinpoint the quantum states of qubits. The use of transformational quantum gates on qubits would be comparable to any computation performed on the neural network as a result. Thus, neural networks used in AI seem to be an ideal match for quantum computers. Additionally, as compared to a classical computer, quantum computers can considerably speed up machine learning. For this reason, Google has been funding quantum computer research in an effort to enhance Google AI using quantum hardware. 4. Quantum cryptography. Since it is not intended to stop quantum computers from breaking cryptosystems, albeit it does so nevertheless, this differs greatly from post-quantum cryptography. The tools of quantum physics themselves are used in this kind of cryptography, what makes it more adaptable than other types of cryptography. Though, the key distribution phase of a cryptosystem, where two pairs of entangled qubits are employed, is the main emphasis of quantum cryptography. The sender keeps the other while sending the first to the recipient. When measured, entangled particles in a superposition have an impact on the other qubit. These qubits can be sent in a stream to create an encryption key. The fact that eavesdropping is impossible because to the qubit's incapability to be replicated is its strongest feature, as there are ways to tell whether a qubit has been tampered with before being received by the intended recipient. They cannot be measured either. As a result, it is a reliable approach for cryptography, which is why researchers are continuously working in this area. 3. Forecasting weather. We've all experienced the situation where we looked at the forecast and saw that it was going to be a beautiful, sunny day. Then, a little while later, it begins to rain and you forgot your umbrella. It appears that there might be a solution for that with quantum computers. The prospect of utilizing quantum computers to predict the weather more accurately than traditional computers was discussed in a study written by a Russian researcher in 2017. The ability of modern computers to predict all the complex changes in weather is subject to some limits. This is due to the massive volumes of data needed. However, due to the dynamic quantum clustering methodology, which is said to produce valuable datasets that traditional techniques are unable to, quantum computers appear to give a significant speedup over classical means. Even said, it is important to keep in mind that no weather forecasting technology, not even quantum computers, can be 100% accurate. Nevertheless, there will be less chance that we will regret not packing an umbrella on dubious sunny days. 2. More efficient customized. We all detest the experience of finding an article we were looking for covered in adverts. Most of it seems to be irrelevant. Fortunately, one of those two issues, the relevance of ads, has a solution thanks to Recruit Communications. In their study, they outlined how quantum annealing can assist businesses looking to advertise in order to reach a larger audience without spending a lot of money. Customers are more likely to click on relevant adverts if they are matched to them using the quantum annealing technique. 1. Gaming with quantum computers. Gamers may be interested in knowing if quantum computers may be used to build a great gaming gear that can run games at blazing high frame rates given all the speedups they offer in the computing sector. The reply would be sort of. The subject of quantum computing is still in its infancy at this time, and the hardware available today hasn't achieved quantum supremacy, the state in which quantum gear can do computations faster than the finest computers now available, albeit the definition is still nebulous. This is due to the fundamental differences in how classical and quantum computer algorithms operate. Quantum gaming yet appears to be feasible despite it. A few video games have been created that make use of quantum computers. One of them is based on the board game Battleships and is titled Quantum Battleship. battleships. Additionally, Microsoft has been developing a programming language called QHash that utilizes both conventional and quantum computing technology. Since it is quite similar to C-hash, it is very likely that games that utilize quantum hardware might be created using QHash. Maybe one day we'll have Call of Duty Q. Subscribe for more.